Okay, we're going to start to look at 3D vectors. 3D vectors are vectors that exist in three-dimensional space as opposed to a two-dimensional plane. Now, a lot of the rules for 2D vectors can be applied directly to 3D vectors. For example, addition, subtraction, multiplication by a scalar, magnitude, position vectors, and we'll look at all of that in the detail within this video. First thing that's new that we want to explore is in the back of some work in 3D coordinates. Okay, if you've got a unit vector, now a unit vector being a vector which has got magnitude of 1. A unit vector, so there I've denoted that it's got a length of 1, a magnitude of 1. A unit vector that travels 1 unit along, okay, that's in the x direction, that can be called the vector I, okay. And a unit vector, so that means again it's got a length of 1 which travels in the direction of the y-axis. That can be called j. And then a unit vector which has got again a length of 1, a magnitude of 1 that travels in the z direction, we can call that one k. Okay, so the vector I then is as a column vector that's 1, 0, 0. So it's 1 along, as we can see. It's 0 in and it's 0 up, 1, 0, 0. J then is 0 along, as we can see, but 1 in and 0 up and down. And then k then is, well, it's 1 up, so that's 0 along, 0 in, and 1 up, 0, 0, 1. So if I was to then, for example, that's just some new terminology that we can use with vectors. If I was to say, for example, then, we'll put 3i plus 5j minus 2k. Well, that could be written as 3, 5 minus 2. If I was to say, what about 4j, for example? Well, the j vector is going in, so that would be 0, 4, 0. If I was to say, for example, 2i plus 5k, well, that would be 2 along, but 0j, so that would be 2, 0, and 5. Okay, then let's say I had a vector which was 0, minus 1, minus 6, and I said to write that in the form I join k. Well, it would be 0i minus 1j minus 6k. Okay, let's say that it was a vector minus 3, 4, minus 7. Okay, so that would be then minus 3i plus 4j minus 7k. Let's say I had a vector t, and the vector t was 0, minus 5, 0. Okay, so 0i minus 5j and 0k. Okay, so that's a quick look at moving from column vector form to in the form ij and k. Okay, so let's say we wanted to add the vector a, which was 3, 5, minus 1, and the vector b, which was 4i minus 5k. Well, let's put everything into component form then. That would be 3, 5, minus 1. And then I'm adding on the vector, so I'm looking for a plus b here. 4, 0, minus 5. And then we just do similar to what we did in 2D vectors. For 3D vectors, you just add together the components. 3 plus 4 is 7. 5 plus 0 is 5. And minus 1 plus minus 5 is minus 6. That's that one. Okay. Let's say we're going to find the magnitude of the vector A, which is I plus 4j minus 8k. Okay, let's first of all put that into component form. 1, 4 minus 8. Now remember that to find the magnitude of a 2D vector, it was the square root of the sum of the square of the components. Well, it's exactly the same for a 3D vector, it's just that there's now 3 components. It's the square root of 1 squared plus 4 squared plus minus 8 squared. And that's the square root of 1 plus 16 plus 64. That's the square root of 81, and that is equal to 9. Let's try another one. Okay. So next one, let's find the magnitude of this one. So 5, 0, minus 5. Okay, so I could have presented that in this form, 5i plus 0j minus 5k, in which case you would just put it into that form. So just be prepared to see it in both forms. So square root of 5 squared plus 0 squared plus minus 5 squared. That's the square root of 25 plus 25. That's the square root of 50. The square root of 50 is a surd, which I can simplify. So let's think about the square numbers between 1 and 100. And I'm looking for the biggest number on the list, which is a factor of 50. Okay, that number is 25. 25 fits into 52 times. So that's root 25 times root 2. Root 25 is 5, so final answer then is 5 root 2. Okay, that's that one. Okay, next one. Let's find the magnitude of 3a minus 2b. And I'm going to say that the vector a then is minus 4, 1, minus 3, and vector b, I'm going to present that in ijk form and say that that is 3i minus 5j minus 2k. Okay, so 3 lots of the vector a, that's 3 lots of minus 4, 1, minus 3, minus 2 lots of the vector b, which is going to be 3 minus 5 minus 2. Okay, so 3 lots of minus 4 is minus 12, 3 lots of 1 is 3, 3 lots of minus 3 is minus 9, minus 2 lots of 3 is 6, 2 lots of minus 5 is minus 10, and 2 lots of minus 2 is minus 4, minus 12 minus 6, minus 18, 3 minus minus 10 is 3 plus 10, that's 13, and minus 9 minus minus 4 is minus 9 plus 4, which is minus 5. Okay, so at that point, we're looking for the magnitude, so it's the magnitude then of 3a minus 2b. Okay, so there is the components, that's the square root of minus 18 squared plus 13 squared plus minus 5 squared. That is the square root of minus 18 squared is 324, 13 squared is 169, and minus 5 squared is 25. Okay, so 169 plus 25, that's going to be 194, 194 plus 324, and that's going to be 518, square root of 518. Okay, now it's worth scrutinising 518 to see if there's any factors that come out, but if you test it and scrutinise it, you'll find that there aren't, so that's a fine answer. Now, within the context of that question, you'll notice that we've already done multiplication of a scalar, which is just when you multiply a vector by a constant value on the outside, and just what you would expect happens there does, which is you just multiply each component by that value outside the vector. Okay, let's now think about the negative vector. Okay, so let's say we had a vector a, which was minus 5, 1, 7. Then the negative vector is just an inversion of the sign. So minus 5 becomes 5, 1 becomes minus 1, 7 becomes minus 7. Dead straightforward. Next one, let's think about position vectors. Okay, so remember that if a vector is given by AB, then it's the components of B minus the components of A. So let's say that I was looking for AB, where A is equal to minus 7, 1, 2, and B is equal to minus 3, 1, minus 5. Okay, so AB then is equal to B minus A. and that's minus 3, 1, minus 5, minus 7, 1, 2, minus 3, minus 7, minus 3 plus 7, that's 4, 1 minus 1, that's 0, minus 5, minus 2 is minus 7, and let's now say that we were asked to find the magnitude. Well, you would just do square root of 4 squared plus 0 squared plus minus 7 squared. That would be the square root of 16 plus 49, and that is the square root of 65, which is a sum that cannot be simplified. Okay, let's now look at points dividing a line. Okay, so we've recently looked at that for a two-dimensional plane. Let's now look at 3 dimensions. Okay, so we've got the point A, which is 4 minus 6, 12. We've got the point B, which is 4, 4 minus 3, and we've got the information that P divides AB in the ratio 3 to 2. Okay, the first thing that I would like to do then is just try and support my thinking with a diagram. There's the point A, there's the point B, and P divides in the ratio 3 to 2. Okay, so I want to find the coordinates of P, and that's the name of the game with this one. So what did we do last time in 2 dimensions, and we're going to repeat it in 3 dimensions. We did 2 lots of A plus 3 lots of B, and then we divided that by a sum of the parts, which is 3 plus 2, and that's 5. So it's going to be 3B plus 2A divided by a sum of the parts, which is division of 5, and we'll write that as a fifth. Okay, I've introduced a rectangle bracket again just to make things very clear. Okay, so that's now 1/5 of 3 lots of the vector B, so that's 4, 4 minus 3 plus 2 lots of the vector A, which is 4 minus 6, 12. Okay, so that's 1/5 of 3 fours are 12, 3 fours are 12, 3 lots of minus 3 is minus 9, plus 2 lots of 4 is 8, 2 lots of minus 6 is minus 12, 2 lots of 12 is 24. Okay, so that's now 1/5 of 12 plus 8 is 20, 12 plus minus 12 is 0, minus 9 plus 24 is 15. Okay, so that is now 20 divided by 5 is 4, 0, 15 divided by 5 is 3. Final move is to write that back as a position and a point 4, 0, 3. Okay, and that's really quite a comprehensive and simple overview of 3D vectors, and as you can see they relate very closely to 2D vectors. It's just extending things with the third component.